A pleasant day, everyone. Welcome once again to our session for today. So, our discussion for today is still on the topic of the derivative as a rate of change. So, we'll focus our discussion today on the motion along a line. Okay? So, another use for the derivative is to analyze motion along a line. And we have described velocity as the rate of change of position. And if we take the derivative of the velocity, we can find the acceleration or the rate of change of velocity. It is also important to introduce the idea of speed, which is the magnitude of velocity. Thus, we can state the following mathematical definitions. So before this mathematical definitions class, I would like to emphasize to you, tell you in advance that what we need to know and remember about this topic is just these three things. So we have S, which is the position. We can call this as S of t. So this is what we call the position of the object. And we have V sub t or V of t is what we call the velocity of the object. And we have A of t is the acceleration. Is the acceleration of the object. Okay, so as mentioned, we have here mathematical definitions about this part of our discussion. So we have, let S of t be a function giving the position of an object at time t. So that's why we have here S of t that give us the function giving the position of an object at time t. And then we have the velocity of the object at time t is given by this, V of t, so meaning the velocity. So V of t is equal to S prime of t. It means this is just the derivative of S sub t and the position function of the object. And the speed of the object at time t is given by this magnitude of V of t. So the absolute value symbol here, class, indicates absolute. The absolute value indicates the magnitude. Alright? This is the magnitude of the velocity. Okay? And then the acceleration of the object at time t is given by A of t, which is equal to V prime of t, and this is also equivalent to S double prime of t. So in other words, our acceleration is just the second derivative of the position of the object given in the function of t. Okay, so these are the basic concept for this part of our application, motion along a line. So we need to remember these three things. Another thing that we need to remember is the established formula about velocity, distance, and time. That we have the velocity is equal to distance over time. Alright, so that's why we have a unit velocity normally expressed in terms of meters per second or feet per second. So numerator meter, distance, denominator seconds means time. So velocity is distance over time. So this is also a very important formula that we need to remember. Alright, so let us have an example, so to give you an idea of how this concept is applied or relates to the topic about derivative. Okay, so we have here an example. In this example class, we are going to compare instantaneous velocity and average velocity. Alright, so we have here a term, a very, I think, a strange term for you or for some, or perhaps for others who were exposed to this kind of topic class, might be familiar or might familiar with this word instantaneous. So what does it mean, instantaneous? Okay, because sometimes if you won't understand the word or the term, so when that word or term is used in the question, then since you don't understand that word, then you will not be able to understand or know what to do. Okay, I will answer that question later on. What is this instantaneous velocity? Of course, when we speak of average, so that's very common. The word average is very common, so I know you are familiar with that one. Alright, so we have here an example. A ball is dropped from a height of 64 feet. Its height above the ground in feet per second or feet per seconds later is given by s of t equal to negative 16t squared plus 64. Okay, so this is our problem. Okay, so to solve this problem, like in our other example, we have to organize our solution to help you understand it more. Okay, so first we have to write down what are the givens in the problem. So we're given the height, no? The height where a ball is dropped, and that is 64 feet. And this is our S. So S sub 0. Okay, what does it mean, S sub 0? So this is the position of the ball at t equal to 0. Alright, then what else? We are given, so its height above ground in feet, t seconds later is given by this. So this is the function, no? The position function, that is s of t equal to minus 16 t squared plus 64. So its height above ground in feet, t seconds later. So t here can be any value. It can be at t equal to 1 second, at t equal to 2 seconds, or at t equal to 0.5 second. Alright, so these are the given. And what is required in the problem? Okay, so the problem says okay, so it is illustrated in this graph. So the requirement is, what is the instantaneous velocity of the ball when it hits the ground? Okay, so we have two requirements. Instantaneous velocity. So just think of it as v sub t. Okay, so we are going to find the v sub t. Then the other requirement is, what is the average velocity during its fall? So velocity average, or average velocity. Alright, so these are the givens. So let us now have the solution. Now for a solution, first we have to find the time. We have to find the time. So find t. So we need to find the time when the ball strikes the ground. Okay? So looking at this illustration here, so at t equal to 0, okay, so this is the illustration, class. So at this point here, at t equal to 0, so we have this vertical line, class. This is the s and this is the t. So s as a function of t, it means that at any value of t, you have the corresponding value for s. So our s here is given as s of t equal to minus 16t squared plus 64. So s is a function of time t. Okay, so when you graph that one, so we have this s axis, we have this t axis. This is the time axis, this is the position axis. So at t equal to 0, it means that before the ball was thrown or dropped to the ground, so that is at t equal to 0. So the height of the ball from the ground is equal to 64, right? So this is 64 at this. So before the ball at t equal to 0, because our t is running towards the right or moving towards the right, so at t equal to 0, the ball is at the height of 64 feet from the ground. So assuming this is the ground here. Alright? Now what happens when the ball reaches the ground? What happens when the ball reaches the ground? When the ball is dropped, what will happen, class? Okay, so in order for us to solve for t, so we have to use this concept that when the ball hits the ground, so when the ball hits the ground, what will be the value of our s, or s sub t? What's the value of our s sub t? So if you look at the graph, so when the ball reaches the ground, okay, so this is at t equal to, assuming that this is the time that the ball reaches the ground, so we can we can say that this is the t final. So t initial, okay, we can call it t initial, initial time, meaning at t equal to 0, that is ti, and the final time, so the time when the ball hits the ground. So our s sub t is equal to, so this will be equal to 0, right? You see, when the ball is dropped at t equal to 0, the height of the ball from the ground is 64 feet. So when the ball is dropped, okay, it dropped this way, so s is decreasing, right? The height of the ball decreasing until it reaches the ground where the height becomes 0. So when the ball hits the ground, s sub t equal to 0. So from here, we can solve for the value of t. Okay, so how to solve for the value of t? So we have the equation above, or the function above, given s sub t equal to minus 16t squared plus 64. So when the ball hits the ground, a sub t equal to 0. So 0 equal to minus 16t squared plus 64. Okay, so from here, we can solve for t. So common on its term, we have 16, or say minus 16. So factor out minus 16, so we have t squared. So factor out 16 here. So this is minus 4 and equal to 0. So equating its factor to 0, so we have minus 16 or you just divide both sides by minus 16. So we have minus 16 times t squared minus 4. So we have here 0 divide by minus 16. So this one divided by minus 16. So this is 0. Okay. So minus 16 divided by minus 16 is equal to 1. So we have 0 equal to t squared minus 4. So solving for t, so we have t squared, or we can rewrite this as t squared minus 4 equal to 0. So transposing this to other side, so t squared equal to 4. Then taking square root on both sides, so we have t equal to 4. So take square root on both sides, t squared, square root of t squared, and square root of 4. So when you take square root, you have two values on the right side. So square root of t squared is t, square root of 4 is 2, so you have plus and minus 2. But since there's no time that is negative, so you just take t equal to 2 seconds. Okay, so this is the time that the ball reaches the ground. Okay, so you have t seconds. So what is now the instantaneous velocity? What's the instantaneous velocity? So for letter A, we have instantaneous. For letter A requirement, instantaneous. Instantaneous velocity of the ball, right? Instantaneous velocity of the ball when it hits the ground. So we call it v of t. So we know that v of t is just the derivative of s sub t. Alright? And we are given s of t equal to minus 16t squared plus 64. So taking the derivative, so we have s prime of t. So applying the constant multiple rule and also the power rule, so this would be negative 32t. So 2 times 16, negative 32. 2 minus 1 equal to 1. Okay, so therefore our velocity is equal to minus 32t. So at t equal to 0, at t equal to 2 seconds, so we have v sub 2 equal to 2 here is from here, 2 seconds. We just substitute the value of t equal to 2. At t equal to 2 seconds, so we have v of 2. This is the value of the velocity at t equal to 2 seconds, equal to minus 32 times t. T is 2. So v of 2 equal to minus 64. So what is the unit? So we are talking of velocity. The given is in terms of feet. Okay, so it means that this is 64 feet per second. Okay, so this is the instantaneous velocity. So going back to the question, what is instantaneous velocity? That is the velocity at the instant that t equal to 2 seconds. Instantaneous at any time t. So that is the velocity. Instantaneous velocity is the velocity at any time t. So instantaneous. So in this particular instant at t equal to 2, so our v of 2 is minus 64 feet per second. Okay? Now, how about the requirement B? So for requirement B, we're asked to solve for the average velocity. Okay, so what's the average velocity? So how will you calculate the average velocity? Okay, so to calculate for the average velocity, so we need to use the idea that is given a while ago, that velocity is given in terms of distance with respect to, or distance over time. So that is the very basic concept about velocity. That's why you will see the unit of the velocity in terms of meter per second. So meter per second means when you have unit meter, if you have a unit in terms of meter per second of the velocity, so meter per second, so velocity meter per second, the units. So meter is in terms of, this is the distance, and second, this is the time. Okay, so velocity is distance over time, right? So we have to use that concept here. But we are asked to solve for the average velocity. So how to calculate the average velocity? Okay, so if you look at the graph here for our reference, so at t equal to 0, meaning at ti, meaning initial time at t equal to 0, which is ti, our velocity is, the height of the ball, the position of the ball is at t equal to 0, s, we have a definition s sub t, right? S sub t, so we have when t equal to 0, so s sub 0, So our S sub 0 is equal to 64. 64 feet. So this is the position of the ball at t equal to 0. At t equal to 0. Now we have solved t. A while ago we have solved t equal to 2 seconds. Okay, so we have solved here t equal to 2 seconds. So that is our final time. So it means that our final time at t equal to tf, so this is 2 seconds. That is done in our calculation. This seconds. This is 0 second. Okay, so what is our s here? So our s here is here at we have this function of the position of the ball. Okay, s sub t. So as t equal to 0, so s sub 0 equal to 64, meaning at t equal to 0, this is the height of the ball. At t equal to 2 seconds, so s sub 2. So what is the position of the ball? This is equal to, so that is the ball is already at the ground, right, or on the ground. So that is equal to 0. So for the second question, we are asked to solve for the average velocity. So the average velocity v av is equal to, is simply equal to the initial. We are talking of distance, right? Distance. So initial distance, meaning this is the position at s sub 0. Sorry, this is s sub 2. We have the final distance, or we can say that that is s sub f, and f is we have this s sub t. Okay, so in this case our t is in terms of final, because we start with final minus initial. So s of tf, okay, tf minus s of ti, then divided by, we have t final minus t initial, so equal to, so stf. So what does it mean, stf? Sorry class, this is stf. This is s sub t, then f. So our s sub tf, what is our s sub tf? This is s sub 2, because our final time is 2 seconds. Final time means the time when the ball hits the ground, and minus s sub ti, our initial time, that was 0 at ti equal to 0 second. Then tf, what is the final time? Final time tf is equal to 2 seconds minus ti, initial time ti, is equal to 0. Then substituting, so we have s sub 2, meaning the distance of the ball from the ground when the ball hits the ground, that is equal to, so you just substitute class. Now when the time is 2, when the time is 2 seconds, so when this is 2 seconds, so 2, okay, when this is 2 seconds, alright, so I can do it here. T equal to t equal to 2 seconds. So we have s sub 2. We're going to substitute it here in this formula, or in this function. So substitute t equal to 2. So s sub 2 equal to minus 16 times 2 squared, then plus 64. Okay, plus 64. So 2 squared, 4 times minus 16, so minus 64. Minus 64 plus 64 is equal to, that is equal to 0. Now at t, this is at ti, at our t here is equal to ti at tf. This one at t equal to 0 second, this is our ti. Okay, so this is our initial time ti, this is our tf. Okay, so at t or ti equal to 0, so you just substitute it here. So we have s of 0 equal to minus 16 times 0 squared plus 64. Okay, so 16 times 0 squared. 0 squared is 0, times 6 minus 16 is 0. So 0 plus 64. So this is equal to 64. Alright, so these are the values that we need to substitute it here. So as s sub 2, which is equal to 0. So s sub 2 is equal to 0. Minus s sub 0, s sub 0 is 64. So minus 64. Then 2 minus 0, that is 2. So therefore, this is equivalent to minus 32 feet per second. So this is the average velocity. So v average or average velocity is equal to minus 32 feet per second. So this is our answer. Okay, so that's it. Now we have a very simple example here, just to emphasize the concept, and I hope you have understood it. Okay, so if you have any question, you may just comment on our video or send your message to our group chat. All right, thank you very much, and have a nice day to all of you, and see you again on our next video, another application of the derivative as a rate of change. Have a nice day, everyone. Keep safe and healthy always. God bless. Bye.